And there it is, the radio is out. I was telling about this button here. Obviously this is a potentiometer, and we can see original light bulb here. It's very interesting. At least it looks like the filament inside is okay. I don't know why it's in green color. We'll see about it. A lot of dust, of course. Hasn't been touched for a while. And there are two electrolytic capacitors here, which are definitely going to be replaced, but I'll probably leave these two here just for the aesthetic reason, and I will connect new ones somewhere below or beneath the chassis. I'll see about that. This is how we tune the radio station. This switch works, but I cannot switch it on and off without a button. That is how hard it is to deal with it. And here you can see two coils, and it's not accidentally positioned like this under 90 degrees because they are trying to reduce influence of one coil to another. And this is a cap that goes to the probably one of the grids on electronic tube. Let's check it below. Now check this out. Look at these resistors here, how beautiful that is arranged. Just gorgeous. Very nice. For the year of manufacturing, this is just beautiful. And this is how wiring is done, and quite common connection simply with a wire in which you put other 2, 3 or more wires you want to connect, and you just solder out that. And here probably capacitors inside, also shielded. And just take a look at this this potentiometer. It's just a simple wire. All in all, that looks pretty nice. We have one massive transformer here, and it looks like it's in good shape. There are a couple of capacitors also that needs to be replaced, because you're always at risk if you leave those capacitors like this one over here. They're under high voltage, and they can end up in flames, literally. So we're not gonna play with that. So I will replace these capacitors, because inside pretty much degrades over time, and the electric material inside is not resistant anymore as it used to be when these were produced. So they can leak very easily. So we will definitely replace them. Everything else looks quite okay. I'll maybe deal with a couple of wires like this. Someone, I believe, yeah, definitely someone has replaced this resistor. It's let's call it new, because it's probably at least 30, 40, not 30, but 40, 50 or more years old. These are definitely older. So this resistor was produced like 1960s or 70s, and take a look how it's soldered here. That is not okay. That is not okay. It's barely holding. It was done just to have the job done, nothing else. And this wire can easily get in contact with other wires as it is here. So you're risking of damaging the radio or even something worse. So yeah, we'll have to take care about that as well. This is also capacitor here, probably like a trimmer capacitor. You can change its value or not. No, it's like a plain capacitor. By marking, it's probably 100 picofarads. but I can check it. I can see what voltage is getting on this capacitor, maybe replacing even that one. It's very simple, primitive, but yet effective way to make a capacitor. But of course, it's much better to put a new one, and everything else looks quite nice. There are a couple of capacitors here as well, and yeah, that's pretty much it. So replacing electrolytic capacitors, replacing those capacitors, and then I'll test it to see on what voltage is set on. I have similar radio, so I can check this wiring here to see if that is okay. And I'll just disconnect these two wires from here and put a power cord on them directly. So I don't want these two pins to be under high voltage when I get power supply to the radio somewhere inside. I'll see how I'm gonna manage to do that. I'll check the resistors that are easy to check at first, and yeah, that's pretty much it. So let's get this job done first. Here is just an example of one capacitor I took off the radio. It's labeled for 32,000 picofarads or 32 nanofarads, and I'm measuring its capacitance here. Should be quite precise, and at the moment we can see where the dip is, and that shows like 27. Scale is times 10, yeah, so it's 27 nanofarads. Should be 32, but as you can see, it's 5 nanofarads down. So it doesn't matter actually if this capacitor could stand the voltage at a moment in this radio. It's quite off the value it should be. So yeah, I'm gonna replace it with a new one, and I'll do the same with the rest of capacitors. I'm eager to see one other capacitor which is 0.1 microfarads or 100 nanofarads. I'll take that one out as well, and I'll measure it. Just gonna be interesting to see what is the value of those capacitors now. Now we can see some progress here. I have replaced a couple of capacitors. For example, like this one over here, that was for replacement for one capacitor. There is one over here, one beneath, and so on. There are a couple of more capacitors like this one here that I need to replace, but I don't have a proper replacement with the correct values at the moment, so I'll have to order new ones, and that will also be replaced. This one is disconnected and replaced by this one. And yeah, that's pretty much it. There are a couple of more over here, and I've added the power cord and disconnected these pins, power supply pins, so it's basically safe now. So if you touch it from the back side, you won't get shocked. So that is fine. And basically the radio is ready to be plugged in for the first test. Here I have a variable transformer, so I can choose any voltage between 0 and 250 volts for power supply. And the aim at the moment is to check what is the voltage for heating for these tubes. I know that they're meant to be powered by 4 volts for the filament, and this is what I'm going to measure now. So that pin over here and this pin are for the filament, for the heating of tube, and I have this small digital voltmeter here, so I will just plug it in the filament pins. A bit hard to do with one hand. Okay, that one and another one here. This will do for the measurement. Now to start the power supply, and starting from the 0, and I'll just monitor the voltage here. So increasing voltage on transformer. Okay, it's raising. Now I'm at about 100 volts. I know there is 10 volts here, like not showing correctly. So this is like 100 volts, and it's 2.2 volts here. So I'm pretty confident that we are at correct setup for power supply. So on 240 there's like 4.6 volts at the moment. So with these jumpers here, we can change the input voltage for the transformer, and I know there is a setup for 240 volts. I think at the moment it's set for 225. I've managed to find a schematic for 240. This one over here needs to go down, so I will move it down, and of course before that I'll get everything back to 0 and even switch it off. So now I will set the radio for 240 volts, and I will start again from the 0 to see if that is going to correct the voltage for like 4 volts, which is going to be good because we are extending life of tubes, because they are not supplied with higher voltage than needed. Okay, now let's make that change and see what's going to happen.